Before plants, Earth's continents were lifeless wastelands of rock and dust. This is the story of the most audacious invasion in history, when life dared to leave the ocean and transform a dead world into a living one. Why would anything abandon the ocean? For 3 billion years, life thrived in water. Safe, stable. Perfect. Then something changed. Around 470 million years ago, tiny green organisms began crawling onto the most hostile environment imaginable: dry land. No rain fell on plants yet, because there were no plants to make rain. No soil cushioned their arrival, because there was no soil without them. The continents were Mars before Mars died, lifeless rock under a burning sun. And yet they came anyway. By the end of this episode, you'll understand why life risked everything to invade land, and how that decision didn't just change life itself, but rewrote the rules of an entire planet. This isn't a story about plants. It's a story about ambition written in chlorophyll, about organisms that looked at a dead world and saw opportunity. How does something with no brain, no eyes, no sense of future decide to conquer the impossible? The answer lies in desperation, chemistry, and an evolutionary gamble that could have ended in extinction. Picture Earth 470 million years ago. The oceans are crowded. Ancient algae, primitive animals, bacteria, all competing for sunlight, nutrients, space. The water is a war zone of survival. But above the waves, nothing. Endless continents of bare rock, mountains eroding into sand, rivers carving through stone, carrying minerals to the sea. The land receives sunlight, abundant, unfiltered, constant. Energy pouring down onto emptiness. Did you know that early Earth's land masses were essentially giant solar panels with no one to use them? In the ocean, you fight for every photon of light. In the shallows, bigger organisms cast shadows. Deeper down, darkness rules. But on land, pure, uncontested energy. The opportunity was obvious. The problem was everything else. Land meant death, desiccation, UV radiation without water's protection. Temperature extremes, no nutrients. No support structure, water holds you up, air does not. Why would evolution favor organisms that climbed toward guaranteed death? The first pioneers weren't technically plants. They were green algae, charophytes, living in shallow pools that occasionally dried up. Most died when the water vanished, but some had a mutation. A simple chemical adaptation, a waxy coating that slowed water loss. Just enough to survive a few hours of exposure. These weren't heroes, they were accidents that didn't die fast enough. How does an accident become an invasion? Evolution doesn't plan. It stumbles forward through survivors. The pools kept drying. The coated algae kept living slightly longer than their cousins. They reproduced. Their descendants inherited the coating. Generation after generation, the pools dried. Generation after generation, the slightly better protected survived. But here's the problem, they were still algae. Single cells or simple filaments, lying flat on wet rocks waiting for water to return. They couldn't move, couldn't grow upward, couldn't reach beyond the splash zone of waves and rivers. To truly conquer land, they needed architecture. They needed to stand. Around 450 million years ago, the first true land plants appeared. Bryophytes, mosses, and liverworts. They looked simple. Tiny, low-growing, almost primitive. But they carried revolution in their cells. Did you know that mosses invented one of the most important structures in biology? Multicellular architecture designed specifically for air. In water, every cell can absorb nutrients directly. You don't need pipes on land, that's suicide. Top cells dry out, bottom cells starve. Mosses solved this with specialized cells that moved water internally. Primitive plumbing, crude but functional. They also developed rhizoids, root-like structures that anchored them to rock and absorbed moisture. Not true roots, but enough. How do organisms without brains coordinate thousands of cells to work together? The answer is chemical signaling. Cells releasing molecules that tell neighboring cells what to do. A biochemical conversation that builds bodies. Mosses created the first terrestrial carpets. They spread across rocks near water. Green films became green patches, became green blankets. But they had a fatal limitation, they couldn't grow tall. Their internal transport system was too weak. They needed constant moisture. They couldn't venture far from water's edge. The land beyond the splash zone remained empty. What they did accomplish, though, was profound. They began breaking down rock. Their rhizoids secreted acids, weak but persistent. Stone slowly dissolved, minerals released. Dead plant matter accumulated in cracks. The first soil, if you could call it that, was a thin paste of rock dust and organic debris. Mosses were preparing the ground for something bigger. But there was another player in this story. One that most people never consider: fungi. Did you know that plants might never have conquered land without forming an alliance with organisms that aren't plants at all? Fungi had already colonized land before plants. They fed on minerals and rock, breaking down stone through chemistry. When early plants arrived, fungi made a deal. The plants had sugar from photosynthesis. The fungi had extensive networks that could gather water and minerals from a wide area. They merged, mycorrhizal relationships, fungal threads wrapping around plant roots, extending their reach 100-fold. The plant feeds the fungus sugar. The fungus feeds the plant everything else. This partnership is so ancient, so fundamental, that most modern plants literally cannot survive without it. How many of Earth's forests exist because two completely different forms of life learned to share? The answer is almost all of them. Mosses and their fungal partners transformed the edges of continents, but the interior remained barren. The deep land, far from rivers and coasts, was still a wasteland. To claim that territory, plants needed more than better plumbing. They needed to break free from water entirely. Here's the existential problem mosses couldn't solve: sex. They still reproduced like aquatic organisms. They released sperm that needed water to swim to eggs. No water, no reproduction. This locked them near moisture. They could never venture into dry continental interiors. What if that limitation was permanent? What if the physics of reproduction meant that plants could only ever be coastal organisms, abundant near water, absent everywhere else? Then Earth's interior deserts remain dead, hundreds of millions of square kilometers of rock and sand, baking under the sun. All that energy wasted. And without plant energy spreading inland, terrestrial animals would have no reason to follow. No food chains, no ecosystems. Land becomes a planetary edge case, interesting only at the margins. Everything important stays in the ocean. But evolution was already solving this problem through the most elegant hack in biology. The question was, how do you have sex without water? The answer would change everything. Around 420 million years ago, vascular plants emerged. Cooksonia, small, branching stems topped with sporangia. No leaves yet, no roots, but something revolutionary hidden inside those stems. Xylem and phloem, specialized tissues that moved water up and nutrients down. Rigid cells with reinforced walls that provided structural support. Did you know that xylem cells are dead? They kill themselves to become pipes. Hollow tubes reinforced with lignin, the same compound that makes wood hard. This was biological architecture on a new level. Plants could now grow vertically. They could lift photosynthetic tissue into uncontested sunlight. They could tap into soil moisture and transport it upward. Why does this matter? Because height is power. A plant 10 centimeters tall captures more light than one lying flat. A plant 20 centimeters tall shades the 10-centimeter plant. Evolution triggered an arms race upward. Over millions of years, plants grew taller, 30 centimeters, 50. A meter. They developed true roots that penetrated deeper, anchoring them against wind and tapping into underground water. They developed leaves, flat surfaces that maximized photosynthesis. They spread inland, following rivers at first, then venturing beyond. But the reproduction problem remained. Then came the spore revolution. Early vascular plants produced spores in vast numbers, millions per plant. Tiny packages of genetic material, wrapped in protective coatings. Wind carried them. For the first time, reproduction didn't require water. It required air. Spores landed hundreds of meters away, kilometers away. They waited for rain, then germinated. Did you know that a single fern can produce 50 million spores in a season? It's a numbers game, most die. But a few land in perfect spots, near water and mineral-rich soil where nothing else competes. Those few become the next generation. Suddenly, distance was no longer a barrier. Plants could leapfrog across continents. By 400 million years ago, simple vascular plants had spread across every landmass. The barren shore was barren no longer. Green covered the rocks. Stems reached upward. Spores filled the air like dust. But these were still small plants. Ground cover, nothing taller than your knee. The world was green, but it wasn't yet wild. How does a planet of knee-high vegetation become a planet of forests? That required one more innovation, one more step. And it was already evolving in the DNA of these pioneer species. The land was claimed, but claiming isn't the same as dominating. These early plants transformed rock into soil, yes. They filled the air with oxygen, yes. They created the first terrestrial ecosystems, yes. But they were vulnerable, short, limited. The real revolution, the one that would create forests, alter global climate, and set the stage for all land animals, hadn't happened yet. Because to build a forest, you need something none of these plants had. You need wood, and wood required an evolutionary arms race that would push plants to heights no one could have predicted. What happens when plants start competing not just for survival but for supremacy? This is HistoPrimordia, where history comes alive. Thanks for watching. Subscribe now and join us for the next episode story.